let's now talk about an inverse of a function. When we talk about the inverse of a function, they can be written now as f to the negative 1 of x, right? That's how we find, that's the representation of an inverse of a function. There are a couple of things that you're supposed to be knowing, that when I have a f of x, if I get its inverse, right, the domain of that inverse is supposed to be the range of f of x. So always know that the domain for for an inverse is the range of the original function, and at the same time, again, the range of the original the inverse is the domain of f of x. Just always remember these rules, right? So basically, when you're finding an inverse of a function, you can only find an inverse of a function that is 1 to 1. You get the point? You can only find the inverse of a function that is 1 to 1. If the function is a many to 1, it's going to be difficult for you to find an inverse. Why? Because the resultant function will be now a many to 1. It will be a 1 to many. Okay, let me say that one more time. You can only find the inverse of a function if the function is a 1 to 1. That's the not, right? The function has to be a 1. This is only for 1 to 1 functions. Right? If we are talking about, because we are saying that when we now have the inverse, we are supposed to be able to get if we now get the inverse, it is just perfect for the original function. You get the point? From this end, I'm supposed to be able to get to this end. From this end, I'm supposed to be getting to this end. So I'll give you an example where it's very difficult for you to have a not 1-to-1 function or a many-to-1 function. Find the inverse of that and you'll see how faulty that will be. Anyways, let's just probably dive into a couple of examples to see if we can actually get something. So suppose that we are given f of x. We're given f of x to be said that f of x is the same, is a mapping 3x plus 4 like this, where x is an element of real numbers, right? So we are saying with this now, the range for this is always going to be equal to what? F of x is going to be an element of real numbers, because if x takes any value, then f of x is going to be taking any value as well. This is a 1-to-1 function that is a domain of x being an element of real numbers as well. Check this out. To find the inverse, you first have to assume that this is y. So I will have this function being written now as y is equals to 3x plus 4. So what I need to do now is to make x subject to the formula. Whenever I make x subject to the formula, I would have obtained my inverse. So here, I will say y null minus 4 is equals to 3x. I will divide this by 3, divide this by 3. So I'm now saying that my x is the same as y minus 4 divided by 3, right? If I have got to this point, I have now obtained my inverse. I just have to write it now in the form of an inverse state. I'll remove the x that I've made the subject to be now f of negative 1 of x. That's now the inverse. Being equal to, I'll remove the y and place this with an x now. X minus 4 divided by 3. That's what I'll be having as my, that's what I'll be having now is my, that's what I'll be having now is my inverse. But x is an element of real numbers. The domain to this was x is also an element, was f of x is an element of real numbers. So I will still need to mention again on this part that x is also an element of real numbers. I hope you get the point. So whenever you write the inverse of a function, you need also to put in the domain for that inverse. And the domain is always the range for this. I hope you have mastered the point. The range for this was x, it was f of x. Okay, so this is the domain for this. So its range now was going to be also x, f of x. being an element of what? Of real numbers. So here we're going to be having the same thing again. F of x now, f negative 1 of x, the inverse is equal to x minus 4, where x is the element of real numbers because these things are supposed to be the same. So the range for this inverse now, the range for this inverse is supposed to be this now. Again, x being an element of what? Of real numbers. That's basically what we were saying with these 2 points here. This was a one-to-one function and it didn't give us an inverse. Let's have another example again that's probably involving a fraction in it. Let's have another example. Okay. For this one, we want to have a fraction now as our, we want to use a function, example number 2. Example 2. For our second example now, let's have g of x being said to be equal to 1 over x plus 1, where x is an element of elements of real numbers. So x is an element of real numbers now, and also x cannot be equal to 1. So x cannot be equal to 1, cannot be equal to negative 1, I mean to say. Because if x is a negative 1 here, negative 1 plus 1 is going to, negative 1 plus 1 is going to give me 0, which makes this an invalid function now because I'll be having 1 divided by 0, which is an undefined solution, right? So I can always see that for this state, my value, if I'm to find the inverse for this, I'll first have to find what? I'll first have to remove this and place this with a y. So y is equal to 1 over x plus 1. And I need to make x subject to the formula. If I do a cross multiplication there, I will see x plus 1 being equal to 1 over y, right? So to leave this with x now, x is now equal to 1 over y plus 1. It's actually minus 1, I mean to say. Sorry for that. Okay. I'll only see this part now. That's supposed to be a minus 1 now, not a plus 1. Because if this one comes this side, it's going to be coming through as a negative 1. So with that now, I'll have what? A minus 1 now coming through. So at the end of the day, I now have g negative 1 of x being equal to 1 over, I remove the y and I place the x minus 1. Again, x is supposed to be an element of real numbers like what I have here is the domain. But my domain here, my x is never supposed to be equal to 0. You get the point? If my x is equal to 0, then at the end of the day, that will affect the value of my, that will affect the value of what? The value of my solution here. Because 1 divided by 0 is an undefined number. So again, x is never supposed to be equal to 0. Because at the end of the day, this is defined whenever the denominator cannot be 0. So this is going to be defined again whenever the denominator is not equal to 0. So this becomes now to be my my solution to be the inverse of g of x with these as its domains. So whenever you write the inverse, it's not complete until you mention again the domain of that inverse, which means the set of values in which that function is defined. We didn't want this to be 0, so neither do we want this to be 0 at the very end of the day. I don't know if you have mastered this, but basically that's it. So when they ask me probably to find g negative 1 of x now, or let's say now they're going to be giving me, let's say, of suppose 0.5. Right? That's now simple because I'm now applying this only to the inverse now. G of negative 1 of 0.5, which means I'm removing the x and I'm placing 0.5. So that's going to be coming through as 1 divided by 0.5, right? Minus 1. 1 divided by 0.5, that's going to be 2 minus 1, leaving me my solution is 1. So just know that whenever they give you a function that needs you to be dealing with the inverse of a given function, first go ahead and find that function's inverse, then you then apply now the value of what? The value of x that they would have given you to actually find the solution. That's pretty much it. Whenever you write an inverse, one point to note, whenever you write an inverse, don't forget to put its domain. If you leave his domain, then it's a little bit incomplete. That's pretty much it.